Hello, my name is Sol Soler, and I'm a philosopher and a theoretical physicist, and I work on consciousness, and I've written the principles of the physics of consciousness. So like Isaac Newton wrote the principles of classical physics, classical mechanics, a few well-defined principles that can be applied to all physical systems. I've written the principles of the physics of consciousness, which can be applied to all physico-conscious systems. So you yourself, for example, you're not just a physical being, you're also a conscious being, so you're physico-conscious. So a complete theory of any human, for example, or any conscious animal will have to be a physico-conscious theory, because we're not just physical objects, we're also conscious. In this lecture, we're going to discuss gravity, the phenomenon of gravity, and again we notice that gravity has objective aspects and subjective aspects. So it's a physical phenomenon, obviously, as described by Newton's law and by Einstein's general relativity, but it's also a conscious experience. At the moment, you are presuming you're in the Earth's gravitational field. I can't imagine where else you would be. You are having conscious experience of the gravitational field, and that is the conscious experience of your weight. So if you get up, move around, you have to overcome the gravitational force acting on you, and you have to give some effort to do that, and you can feel this weight, you can feel your inertia. So gravity is not just a physical phenomenon, it's also a conscious experience. So any complete theory of gravity will necessarily must be a physico-conscious theory of gravity. To completely describe gravity, because it's not just a physical phenomenon, it's also a conscious experience. And we're going to apply the principles of the physics of consciousness to the phenomenon of gravity and quite fully explain the phenomenon of gravity. We have Newton's law of gravity and we have Einstein's general relativity, but they only describe the objectively measurable aspects of gravity, and they don't include consciousness whatsoever. So those theories are actually incomplete to describe the entire phenomenon of gravity, because gravity is also a conscious experience. So we're going to expand both of those theories so that they include the conscious aspects of gravity and not just the objectively measurable aspects of gravity. Okay, so just before we begin and get into gravity, I just want to say a couple of I just want to explain so that people are aware. I think people need to be aware of this. I think it's very important. For a long time, consciousness has been considered a scientific mystery, and now that mystery has been scientifically solved. So I just want to now that's quite a claim to make. So I just want to justify that claim, explain why I'm making that claim, and justify it. So, for example, we'll work by analogy with Newton's mechanics. So Newton's law of gravity and his three laws of motion. And we'll explain why Newton's laws were accepted and considered true, and then we'll show that the case is exactly analogous with my principles of the physics of consciousness, and then we'll talk a little bit about why, if the mystery has been solved, then why is it not being recognized as solved just at the moment? Obviously it will be, but why is there some delay? So let's take Newton's law of gravity, because that's what we're talking about in this lecture. Before Newton, there were plenty of theories of gravity, many theories of gravity. The most famous theory of gravity before Newton would be Aristotle's theory of gravity, where he said that objects fall to the center of the earth. He basically just said it was in their nature to fall. It was a very vague theory. It didn't say much at all. What you couldn't do with Aristotle's theory, that you can do with Newton's theory, is it's not generally applicable to all gravitational systems. The thing about Newton's law of gravity is and his laws of motion as well, is that you can apply them generally to all gravitational systems and all mechanical systems. Newton's laws work for all mechanical systems. This is why they became accepted as true, because you could take Newton's laws, Newton's principles, his laws of motion, F equals ma, and the law of gravitation, and you can apply them anywhere. You can apply them to the moon going around the Earth going around the sun spiraling around the black hole at the center of our galaxy. Newton's law of gravity will explain all of those different systems. Not exactly, because a more exact theory exists in Einstein's general relativity, but to very great accuracy. For example, with our solar system, Newton's law of gravitation explains our solar system to an incredible level of accuracy. And indeed, when NASA put Neil Armstrong and Buzz Aldrin on the moon, they used nothing but Newtonian mechanics to work out where the moon would be and how much to accelerate the rocket and all those different problems they had to solve. Okay, so Newton wrote Principia Mathematica, and he had some simple, well-defined principles and laws, very few in number, that encapsulated all the essentials of macroscopic motion in our universe, so that you could use these principles in general, and anyone could learn these principles, and then anyone could pick a particular system, a particular dynamical system, and apply Newton's principles. And it was found, and on doing this, it was found that Newton's principles worked for all macroscopic dynamical systems. That is, all macroscopic movement. There's the three-body problem, which hasn't been solved, which can't be solved by Newton's mechanics. But pretty much every dynamical macroscopic system you can apply in a well-defined way. You can apply Newton's principles to analyze it. Okay, and that is why Newton's principles are considered true, because they're generally applicable to the phenomena of the universe. Anywhere, any phenomenon, any system, you can apply them, as long as you're talking about macroscopic movement. Like, Newton's laws don't work for microscopic things or for relativistic things, but they do work over a very large realm of phenomena. So after Newton published Principia Mathematica, it took about 300 years before physicists, scientists would consider that Newtonian mechanics was complete. Because what he did was give the general principles, and he applied it to a number of different systems. But then future scientists, his contemporaries, and then scientists that came after him, they applied it to many, many more systems, until about 300 years later, we could say that Newtonian mechanics was complete or exhausted. We had applied it to every possible macroscopic system we could think up. But yeah, the point is that Newton did not complete Newtonian mechanics himself. It took hundreds of years just because there are so many systems to analyze. What Newton did to prove his principles were correct was he applied them to a number of very important systems. So he proved that his principles were correct by correctly explaining the motion of the planets around the sun. He explained the tides. I can't think of, off the top of my head, I can't think of any other systems that Newton did himself, but he would have applied it to many different systems. But yeah, the most important was the solar system and the moon and the tides. So he didn't answer every question using his principles. He didn't analyze every possible system. Of course, that'd be too much work for one person to do. But he showed that these principles could be applied generally. Now, that is exactly what I have done using the principles of the physics of consciousness. And that's why we can say that the scientific mystery of consciousness has been solved, because these principles have general applicability. They can be applied. It takes some work, and you have to learn how to use the principles. You have to study them. It's the same way you have to study Newtonian mechanics. A teenager needs to spend 3 or 4 years at least in school studying Newtonian mechanics to learn how to apply them. My principles are much easier to learn. They're much simpler, and that's primarily because, with Newtonian mechanics, first of all, you have to learn how to use calculus, because calculus is essential to Newtonian mechanics. Okay, but yeah, so then with my principles, what I have done with my principles is I've used them, like Newton explained the solar system and the tides. These were very big questions at the time, during Newton's day. What I've done is applied my principles to quantum mechanics and have given the first logical, intuitive, understandable, comprehensible interpretation of the experiments of quantum mechanics. All of the experiments of quantum mechanics can be explained using my principles. And now what I'm showing is that these principles also make sense of our canonical theoretical physics concerning gravity, and also special and general relativity. So these principles of consciousness explain, are the means by which we add consciousness to our physical understanding of gravity and space and time. Because you've got to, of course, remember that, for example, time figures in physics. Obviously, physics is a description of how things change with time as time passes. But in conventional physics, when you're talking about time, you're just talking about how many seconds a clock has measured, which is a physical process. You've got to bear in mind that time is also a conscious experience. The passage of time, you are consciously experiencing now the passage of time. So time is not a purely physical thing. It also, like gravity, is a physico-conscious thing. So a phenomenon. You are conscious of the passage of time. And the only reason we suspect that time exists at all is because we're conscious of it. If none of us were conscious, we wouldn't be discussing time at all, because we wouldn't be aware of it in any way. So time is as Immanuel Kant, the great German philosopher, pointed out, time is fundamentally a priori a conscious experience. So for a complete theory of time and space and gravity, these theories must be physico-conscious and not purely physical theories. So my principles can be applied in a general way to any physico-conscious system. Some systems will be more difficult to analyze than others, but that's the same in Newtonian mechanics. Some systems are more complicated and difficult than others, but my principles have general applicability. That's how we know that they're correct. You can apply them anywhere, and they successfully work with quantum mechanics. They successfully work with Newton's law of gravity. They successfully work with special relativity, explaining time, the passage of time, and they successfully work with general relativity. And what's more, another very important aspect or property of my principles is that they also align perfectly with everyday human conscious experience. And you must bear in mind that the only conscious experience you have ever experienced is your own. You have never experienced anyone else's conscious experience. That's a very important fact, because it means the only evidence of consciousness you have, the only evidence of consciousness I have, or any human has, is their own personal conscious experience. So if we want a good theory of consciousness, it must make sense out of our own personal everyday human conscious experience, as well as time, as well as gravity, as well as quantum mechanics. And my theory does that because it aligns perfectly with what it's like to be a human, which is you have some conscious perception and you make conscious choices all day, and you have some limited free will, as in you don't get to control the whole universe freely, but there are some things that you can control freely. You can control the position of your body and things like that quite freely. You can, decide to clap your hands now, or click your fingers, or salute, or any of, you have limited free will over the position, configuration of your body. You can control your thoughts, what you think about. So my theory, free will is, as I discussed in previous lectures, free will is intrinsic to my theory, just like it's intrinsic to human conscious existence. Okay. So, and yeah, these principles are teachable, which is very important. You need for a successful, a valid scientific theory, it must be teachable. The principles must be very well defined, and you must be able to teach them, and other people must be able to apply them, which is the case with my theory. It has been solved, and another reason we can tell it's been solved is because there is no other theory. There just is no other theory that actually that has simple, well-defined principles and that can be applied to conscious systems to analyze them. If there was another theory, then consciousness wouldn't be considered a mystery. The fact is that there hasn't been any theory that actually works. So another reason we can know my theory is true is because it's the only one that actually you can do anything with whatsoever. So then the question immediately is, so why isn't this, why isn't this being accepted? Why isn't it big news? I mean, people have been waiting for centuries for the solution to the mystery of consciousness. So why isn't this being accepted? Well, that's a very complicated question with a complicated answer that has to do with human psychology and doesn't have to do with physics or the truth about consciousness. It has to do with human psychology. So there are different reasons why people aren't. It's quite reminiscent of the Copernican Revolution. So let's begin now. So we'll start analyzing gravity now. So the first thing we need to do is, and we're going to begin with an analogy to the Copernican Revolution, and work from there. Because the first thing we need to do, and I've done this in previous lectures. So if you've listened to my previous lectures, you'll have heard this before, but it is good to hear these things again. It is new physics, so you can't learn new physics just by reading it or hearing it once. You need to some repetitive effort to build these models in your mind, so that you could, because what we're doing is we're making a model of the universe using simple principles, or model of different aspects of the universe, different systems within our universe, using well-defined principles to make models with our own imagination, because that's what physicists do. Einstein came up with his theories in his imagination by imagining different aspects of the universe within his own head. So you have to make some effort to learn how to build these physico-conscious models in your mind. So the first thing we need to do is get the fundamental postulate clear. And this will also give us insight into why my theory is taking some time, why there's some delay in it being accepted. Okay, so let's begin with the Copernican Revolution. Just take a quick look at what time I'm at. Ooh, okay. So that already took 19 minutes. Okay, well, here we go. So the Copernican Revolution. Before Copernicus, everyone thought that, or the scientific establishment thought, that the Earth was in the center of the solar system and that the sun and the planets go around the Earth. So every single model they made of the solar system, they put the Earth in the center. Now here's the problem. The Earth isn't in the center, so therefore none of their theories were good. The Ptolemaic theory was the best theory that puts the Earth in the center, and it is a very impressive theory. But it's convoluted and it's a mathematical nightmare, but it does work. It works to some extent. However, it's not compatible with Newton's laws of conservation of momentum and things. So, but Newton's laws came later, so they wouldn't have known that at the time. But yeah, it's not compatible with Newton's laws. And it's very, very complicated. It's very convoluted. And yeah, it's a bit of a nightmare, really. But it's an impressive construction of a theory. But all the scientists before Copernicus were putting Earth in the center. And because the Earth isn't in the center, obviously you can't come up with a good theory that aligns with the truth, because your primary assumption is incorrect. Very, very, an exactly analogous situation is taking place in the study of consciousness. For hundreds of years, scientists have assumed that the basic energy and matter, that is, energy, photons and matter, electrons, protons and neutrons, that the basic fundamental stuff of our universe is non-conscious. That is their fundamental assumption. And you can check this. Look at any physics text for the definition of an electron or something like that. You will find consciousness is not mentioned whatsoever. It doesn't figure at all. So then you have, so the fundamental assumption of modern science for centuries now has been that the basic energy and matter is non-conscious. And to put it technically, would say that the energy that came into existence in the Big Bang was non-conscious. That's what all scientists, except for me and some others, but the vast majority of scientists, of consciousness, assume that the energy that came into existence in the Big Bang was non-conscious. So they start all their theories with that assumption. That's their primary assumption. That's like putting the Earth in the center of the solar system. And this is the reason why consciousness has remained a scientific mystery for so long, is because that's the wrong assumption. In science we call assumptions postulates. It's the wrong scientific postulate. The correct scientific postulate is that the energy that came into existence in the Big Bang was conscious, intrinsically conscious. And therefore all the particles that formed out of that energy are conscious. So each electron, each proton, each neutron is a singular conscious entity, has a single center of consciousness within itself, is actually a conscious creature basically, but it's an exceedingly simple one that lives an exceedingly simple life, conscious life. It has no brain. It doesn't have a complicated brain like a human, and it's our complicated brains that allow us to speak and do all these, and learn mathematics and do all these amazing complex have all these complex conscious abilities. An electron, for example, does not have complex conscious abilities, but it does have conscious experience, and it does make conscious choices. It does have conscious sensation of the forces acting on it. Just like you have the conscious sensation of any forces acting on you, so does an electron. And if an electron goes into a strong gravitational field, it will feel the force acting on it. It won't say, whoa, I'm feeling such a force, because it doesn't have any linguistic ability. But neither does your dog or an octopus or a jellyfish. They still feel forces within themselves. And do bear in mind that you feel forces sometimes without having to say anything, without any verbal narration taking place. You just consciously feel a force without saying anything or without reflecting on it. Like if you're in a car and it starts accelerating, you get pushed back into your seat and you are conscious of that force acting on you. Okay, so that's very simple, basic conscious experience corresponding to the most simple, basic, and most fundamental physical phenomenon of our universe. Okay, so that's the correct assumption. How do we know it's the correct assumption? Well, because we can actually begin to do real physics with it. When we use the other assumption, that all the energy that came into existence is non-conscious, well, no theory of consciousness can be constructed that makes any sense, or that does anything, or that can analyze any conscious system. How do we know this? Well, because there are thousands of these theories of consciousness that try and explain how consciousness somehow switches on, and they just do not work, and they're not valid science. It's bad science. You can check these. A lot of it is just plainly and simply just nonsense. It's a bit of a disastrous situation, to be honest. It's a bit of a philosophical. It's not good anyway. So you get theories like saying, oh, consciousness comes from some hidden dimensions that we can't measure. Like string theory is just for your FYI, string theory is extremely bad science because it's not real science, it's not real physics, because string theory relies on this idea that there are more dimensions, but these dimensions are curled into each other so tiny that we can't possibly physically detect these extra dimensions. And that's cheating. If you try and explain something by saying, oh, well, there are these things that exist, but we can't possibly ever physically detect them or have any physical experience of them, that's not valid science. You can't do that, which a lot of people have pointed out about string theory. But then, you'll get theories of consciousness saying maybe consciousness comes from these extra dimensions, or consciousness is being broadcast from somewhere, and our brains are an antenna for consciousness. And, there's just, I could talk for a long time on all the different logical and philosophical problems here. Where is this consciousness being broadcast? Is the consciousness made out of energy? In which case, why can't we, pick it up? Why can't we detect it? If it's not made out of energy, then what is it made out of? Because according to science, everything that has physical existence is made out of energy. So just a superabundance of theories that just aren't real science. But when we use the correct postulate, which is that all energy is intrinsically conscious and always has been, we can immediately start doing real physics. Because we can apply that postulate to our canonical, our already accepted physical theories, and it aligns with them perfectly. Okay, and also, you really shouldn't be shocked at the idea that energy is intrinsically conscious, because that's what we're saying. We're saying energy is intrinsically conscious. The Big Bang happened, energy came into existence, and this energy within itself is conscious, has conscious experience. Now, the Big Bang, what type of conscious experience would that have been? We can't say at the moment. As the physics of consciousness progresses, I think we will be able to start meaningfully answering questions like that. But at the moment we can't say, but we also, you can't say what the conscious experience of an earthworm is, or what the conscious experience of your gut bacteria is. But we do know that they're conscious, and we know that plants are conscious, for example. The point, just to reiterate the point, that our understanding of consciousness must necessarily begin with and move outwards from our understanding of human consciousness, because human consciousness is the only consciousness we ever experience. And then, from understanding human conscious experience, we can understand other creatures' conscious experience. For example, we have eyes and a stomach and different parts of our body like that. A dog has eyes and a stomach as well. So we can watch a dog and say, okay, the dog is hungry. It's clearly, you know when your pet dog is hungry, and we can imagine that it's having the similar sensation of hunger in its stomach that we have when we're hungry. But it does have to work from you do always have to work from your own experience of consciousness first, because that's the only evidence of consciousness you have. And then you work by analogy. Okay, but you shouldn't be surprised at the idea that energy is intrinsically conscious at all. Why not? Well, because according to science, all that exists in our universe is physical energy. And that's all you're made out of, according to science. There's just, if we inspect your body, take it apart piece by piece, we will just see energy and particles. And you are conscious, and you're conscious throughout your entire physical body. You can pay conscious attention to your foot or your elbow or what have you, and it's all conscious. Now, the simplest explanation of that is that all the energy is conscious. That would explain why you have conscious experience throughout your entire physical body. Now, someone pointed out recently, oh, you say that, but then I don't have conscious experience of my pancreas, this person said, which is a good point, but it's easily understood. The way human consciousness works is we have a central nervous system, which is a very complex piece of conscious technology that's taken millions of years to evolve. And your central nervous system, like its name suggests, and like your conscious life suggests, creates one singular center of consciousness, and that's you. And this singular center of consciousness is conscious of everything you perceive and also makes choices on behalf of your entire body. So, for example, you decide where your body goes from your center of consciousness. That's why you feel like one individual conscious creature, because you are. It's just this, your conscious experience is within your central nervous system, and it's one singular center of consciousness. So your central nervous system extends nerve fibers throughout your entire body. All those nerve fibers are conscious as well, and they send conscious transmissions of the conscious experience of your body. Now, the thing about your pancreas is it's not connected. There aren't nerves embedded. Your central nervous system doesn't have nerves embedded in your pancreas, and therefore you don't have conscious experience of your pancreas because there are no nerves in there. Why? Well, because having conscious experience of your pancreas confers no evolutionary advantage. So where do you have a lot of nerve fibers? You have a whole lot of nerve fibers in your fingertips, for example. And that's why you have very detailed, sensitive, refined conscious experience of your fingertips. Then on your elbow, you have less nerves embedded in your elbow, and you have less conscious, less detailed, less refined conscious experience of your elbow. Why? Well, you don't need any, in terms of evolution, you don't need conscious experience of your elbow. You don't need refined conscious experience of your elbow. But you do need refined conscious experience of your fingertips, because you use your fingers as multi-purpose tools. And the more conscious sensation you have of them, the more delicate your control over them is, which confers more evolutionary advantage. So that's why you don't have conscious experience of your pancreas or conscious experience, within certain parts of your body. But you do have conscious experience throughout your entire body where your central nervous system is extended to. And your conscious experience is more detailed in proportion to how many nerves are embedded in the particular part of the body. Okay. Right, so it's not surprising at all that energy is... it is a big surprise. I'll tell you why it's a big surprise. It's a big surprise because you've been living in the scientific world. So, bear in mind, your beliefs about the universe aren't really your own. Your beliefs about about the fundamental nature of the universe aren't really your own. Your beliefs about the fundamental nature of the universe belong to Isaac Newton, Albert Einstein, and people like that. So... yeah, your beliefs about the universe aren't really your own. And for the past few hundred years, you've been living in a scientific universe, where the scientists are telling you that the basic energy is non-conscious and that human consciousness is just a kind of anomaly in an otherwise cold, dead, non-conscious universe. So, you can't help but believe that because that's what you've been told for so long. And, that's why this theory will take a little while, because it's very revolutionary, because to go from a universe that's just totally cold and dead and has had no conscious experience for 14 billion years, it's just been a physical clockwork thing with no feelings or conscious experience whatsoever. To go from that understanding of your reality to understanding that, the universe has been conscious for 14 billion years and has made all manner of different conscious entities out of itself, including particles, but also atoms and chemicals, and the sun. The sun is a conscious entity as well. It is a big shock. However, it's also the truth, because this assumption makes all of our modern scientific theories cohere and make sense together, and it actually synthesizes them, which is how humans decide that something is true, when it explains when simple postulates explain a large range of different phenomena. Okay, so, and as I said earlier, the principle of the theory of intrinsic consciousness, where all energy is intrinsically consciousness, it explains quantum mechanics for the first time in a simple, logical, intuitive way that anyone can understand. So check out that lecture called The Truth About Quantum Mechanics and Consciousness. But as we're going to show now, it also explains Newton's law of gravity. And in part 2 of this lecture, I'll explain how intrinsic consciousness makes sense of special and general relativity as well. So the fact that it explains all these things in a coherent way and can be applied to any system and also makes sense, any conscious system, and can also make sense of human everyday consciousness, puts it totally beyond all reasonable doubt. And it is very important knowledge, but yeah, obviously there are a lot of scientists of consciousness who are basically angry at me, or so it would seem, extremely hostile, but you know, they have their own theories that they want to be true. But anyway, the truth obviously always comes out in the end. And you can check, am I saying anything illogical? So do make sure to make up your own mind, because we live in a modern world, which is very anti-spiritual. The thing is, this theory of intrinsic consciousness is the first physical theory, strictly, rigorously physical, scientific theory that has undeniable spiritual implications. Like, once you come to understand this theory and see that it is definitely true, I mean, that means a change in the universe you're living in. And I went through this change personally. At first, I was in a universe where everything was just dead, and human conscious life was just a mysterious freak accident that just turns on very briefly, and then you die, and then you're eternally annihilated, which was that's atheism, and it's terrifying. And yeah, humans find it psychologically impossible to cope with, which explains the modern world and all its irrational behavior. So to go from that universe to one where the universe has been conscious since the beginning of time and has spent 14 billion years thinking and arranging itself is a very big change. But thankfully, it's very, very good news. Very good news. Because as I say, it's impossible for a human psychologically to cope once they've experienced existence, conscious existence, and happiness and love and all these things. It's impossible for them to be at peace with the idea that they're going to be eternally wiped out of existence, which is why so much of modern culture is about ignoring our mortality and just grasping as much pleasure and money as you can get in this one particular lifetime. So that's okay. Well, let's leave that for a different lecture. We're supposed to be talking about gravity. So how do we apply the principles of the physics of consciousness to gravity? Okay, well, what principles will we need? We will need the fact that all the energy that came into existence in the Big Bang was intrinsically conscious. We need that principle. And that energy created conscious particles out of itself, and these conscious particles bound together into more and more complex forms, and over billions of years they've formed complex configurations, conscious configurations as complex as humans, that are so complex we're capable of reflecting on our own existence. An electron or a dog, for example, can't reflect on its own existence and start analyzing its own existence mathematically like we have done. Like we analyze ourselves and the universe and deduce the most basic laws and principles by which our universe operates. A dog or an electron can't do that. And we can do it because we're so complex, but that's taken years, billions of years of evolution. Then we need the principle of similar forms. What is the principle of similar forms? It just states that when you take some conscious energy and configure it into something, its conscious experience is dependent on that configuration. And if you have two conscious objects, the more similar they are physically, the more similar their conscious experience within themselves will be. Now, this makes perfect sense of your everyday experience of human consciousness, because humans obviously have similar conscious experiences to one another. That's how we're able to communicate and fall in love, and etc., etc. But the reason we have similar conscious experiences to one another is because we are similarly physically configured. So all of us are configured out of basic conscious energy, and when you configure that energy into a human eye and connect it to a human brain, and it's working, those physical processes are working, the conscious experience you have within that system, within your eye, within your brain, is human visual conscious experience. And we have similar visual conscious experience because we have similar eyes. We have similar auditory conscious experience. That is, we can hear humans can hear within the same range as one another because our ears are constructed in similar ways. We have similarly configured tongues and stomachs and digestive systems, so we have the same conscious experience of eating different things and digesting things. Obviously, there are some differences. Some people are allergic to something that other people aren't. But that, of course, if we examine their bodies, we'll see physical reasons for one person being allergic where the other person isn't. Or, you might have different visual experience than me because you're colorblind, but then we could look at your eye and see the physical reason why you're colorblind, which gives rise to the difference in your conscious experience where I can see red and you can't see red, for example. I don't know much about being colorblind, or maybe which colors you can or can't see. But yeah, the reason you can understand what I'm saying now is because you have a brain that is similar to mine with similar linguistic centers, and that brain has spent a long time listening to English, and that listening to English affects the linguistic centers of your brain until you can consciously comprehend English. So that's the principle of similar forms. So, for example, let's give an example. Electrons are identical particles. They're exceedingly simple. And they're also magnetic particles. So if you put an electron in a magnetic field, it has some conscious experience of being in that field within itself, just like you have conscious experience of being in the Earth's gravitational field. Now, since two electrons are identical particles, identical configurations of conscious energy, if you put them in the same magnetic field, they will both have the same conscious experience of the magnetic field. Then some differently configured entity will have a different experience. For example, you could take as I said, an electron is a magnetic entity. That is, it has spin. So that causes it to have a particular physical and conscious experience within a magnetic field. Take a particle that doesn't possess spin, and it won't have conscious sensation of being in a magnetic field because it's not a magnetic entity. But you take a particle and put it in a gravitational field, it will have conscious sensation of the gravitational field because all massive particles are affected by the gravitational field. Okay, so those are really the only principles we'll need. And now we can start thinking about gravity. So in this particular lecture, we'll focus on Newton's law of gravity. And then in part 2, sorry, I get very thirsty talking for this length of time. In part 2, we'll look at Einstein's theories of special and general relativity and explain the physics behind our conscious experience of time and space, and relative time and relative space. Okay, but we'll begin with Newton's law. And we'll show how we turn Newton's law from, we expand Newton's law so that it's not just a law concerning the objective physical aspects of gravity, but it's a law that also exactly explains our conscious experience of gravity. And then we have a physico-conscious theory of gravity. And it's well to understand that physics works by way of expansion. Okay, so what we're doing is, and you know, you expand on what already exists. This is more theoretical reasons why we can see that my theory is correct, because it doesn't do away with any of our accepted theories of physics. It expands them. So yeah, like to create theoretical physics, what Isaac Newton did was he took concepts from philosophy. That's why he was called a natural philosopher and not a physicist. He took concepts from philosophy such as force and mass, and he combined them with mathematics to create physics. So the creation of physics is about combining different areas of human understanding to create a bigger subject. So that's what we're doing here, really. We're taking physics as defined by Newton and Einstein, and we are expanding it by adding consciousness a priori, by adding conscious experience to all the energy of the universe. So our objective physics what is objective physics? It's where you make a mathematical map of the universe, or a mathematical map of systems in our universe. And what the physics of consciousness does is it just colors in that map with conscious experience. So we are actually able to deduce the conscious experience that particular systems are having by analyzing their physical configuration and their physical processes. Okay, so now we expand Newton's law of gravity, so it makes so it's a physico-conscious theory and not just a physical theory. So this is really simple. Newton's law of gravity is really simple. So this is really simple. So Newton's law of gravity is called a universal law. So that, you know, Newton's famous for discovering universal laws that apply throughout the whole universe. So you're in the Earth's gravitational field at the moment, and you're experiencing the effects of that gravitational field. And when we say a universal law of gravity, what we mean is if you went to some other planet that's not the Earth, if it had the same mass as the Earth, the same dimensions and mass as the Earth, and you were standing on it, you would have exactly the same experience. Like if you measured the gravitational force on this other planet, so some twin Earth in some different solar system, let's say in some different galaxy, there's a planet that's, you know, physically exactly like Earth. If you went and measured the gravity there, it would be exactly the same as on Earth. Objects would accelerate at a rate of 9.8 meters per second near the surface of this planet. Because if the dimensions were all the same, then we apply Newton's law, which is general, it's universal, and we'll get the same result. So that's what we mean when we say Newton's law is a universal law. So what I'm saying now, how we're expanding this, is we're saying that gravity is also a universal conscious experience. So you're on the Earth at the moment and you have the conscious experience of your weight, the conscious experience of the gravitational field. And if you go to an exactly similar planet, you will have the exact same conscious experience. You won't be able to tell that you're on it based purely on the experience of the gravitational field. You won't be able to tell that you're on a different planet. It will be the same conscious experience of weight and inertia. So gravity isn't just a universal law, it's also a universal conscious experience. Okay. Oh, and I should mention, if all energy is conscious, then all physical processes are also conscious processes. And this explains why neuroscience works the way it does. What is neuroscience? Neuroscience is where we scan the brain and we examine what the neurons of our brain are doing whilst we have some particular conscious experience. And we can see that that specific conscious experiences reliably depend on specific physical processes. So the simplest way of understanding this is that all the neurons are conscious, and when they have particular conscious experience, particular physical processes, when they undergo particular physical processes, such as a region of your brain firing, it gives rise to particular conscious experiences. So that's why when you look at something, it always activates the same parts of your brain in the same way, giving rise to the same conscious experience. Okay, so all physical processes are also conscious experiences. So let's, and similarly for an electron in the Earth's gravitational field will have one conscious experience, and an electron in on this other twin Earth planet that we discussed will have the same conscious experience there as well. So this universal conscious experience is true for all conscious entities. All conscious entities experience gravity in the same universal way, in the same way that all massive objects experience a physical force acting on them. So let's look at Newton's law in a bit more detail. So Newton's law says that the gravitational force acting on an object, so we'll take the Earth as one object, and yourself, because the law is written F, the gravitational force, equals minus G m1 m2 over r squared. Okay. So we'll take m1 to be the Earth, just like Newton did, and we'll make the same approximations he made. So we'll say it's spherically symmetric, exactly an exact sphere. We'll ignore. And we'll take the other object. M1 is the Earth, M2 can be yourself, for example. So the force between you and the Earth is given by minus G M1 M2 over r squared. So first we'll explain the minus. Why is there a minus there? Well, that's because gravity is attractive. If gravity was repulsive, then that would be a plus. And then you would, if that suddenly changed, you would fly away from the center of the Earth at tremendous speed. Because now gravity wouldn't be pulling you towards the Earth, it would be pushing you away from the Earth. So that's why the minus sign is there. Then we have M1, M2. So that just means that all massive objects exert a force on all other massive objects around them. Okay? So you have to multiply, and each unit of mass of each object affects each unit of mass of any other object. Okay? So, for example, if you're in the gravitational field of the Earth, and then we make the Earth an extra kilogram heavier, we add a kilogram of mass to the Earth, that extra kilogram of mass will exert a force on each kilogram of your body. It won't just affect adding an extra kilogram to the Earth won't affect just 1 kilogram of your body. It will exert a force on each kilogram of your body. So we have to multiply each kilogram of the objects together. That's why it's M1, M2. If 1 extra kilogram just affected 1 kilogram of your body, then the law would be, mathematically, it would be different. Then it would be minus G M1 plus M2 over r squared, but it's not. That's not how gravity works in our universe. Each kilogram affects each kilogram of in every other body. So you have to multiply all the kilograms together, M1 multiplied by M2. So that explains M1, M2. Now we need to explain G, and we need to explain why we divide by r squared. Now we have to be a little bit careful with G, because G is a constant. It's called the gravitational constant. But G is actually 2 constants multiplied together. It's not just one constant. It's 2 constants multiplied together, and then they just take that result and give it the letter G. Okay. So what are the two constants that are multiplied together to get G? One we can call G prime, and that is just a measure of how strong gravity is in our universe. If G were big, like if you take 2 kilograms and put them at a distance from one another, they will attract each other gravitationally. And let's say you made G, let's say you're in another universe where you measure G is bigger, G prime is bigger. Then the two objects will attract each other more forcefully. If G is smaller, then the objects will attract each other less forcefully. So G prime is a measure of the strength, just the fundamental strength of gravity in our universe. So this could be stronger or smaller, and then that would affect how quickly the universe expands and whether the universe will collapse in on itself again or what have you. And we experimentally we measure this. So we can say what is the force exerted by 2 kilograms on one another if they're a meter apart from one another, and we measure that force. And if G prime were bigger, that force would be stronger. If G prime were smaller, that force would be smaller, weaker. Okay, so that's one part of G. Then the other part of G is actually, it's 1 over 4 pi. 1 over 4 pi. So in mathematics and in physics, when you have two constants in an equation, it's conventional to just multiply them together and just write it as one constant, because they're both constants, they're not going to change. So you just multiply them together and rewrite them as one constant. In this case, that actually makes things more confusing, because then when people study Newton's law of gravity, they don't see the 4 pi, the 1 over 4 pi that's there. The law of gravity makes much more sense if you have that 4 pi, that 1 over 4 pi explicitly out in the equation. Because then we can see that the equation is the force equals G minus G, or G, we called it G prime, without the 4 pi, minus G prime M1, M2, divided by 4 pi r squared. So now the 4 pi, because it was 1 over 4 pi, if you remember, it's underneath in the denominator with the r squared. So then we can see that we're actually dividing the force by 4 pi r squared. And you should be like, that should make you wonder, why the hell are we dividing by 4 pi r squared? I ask a lot of physicists, why do we, in my own personal surveys, why do we divide by r squared in Newton's law of gravity? And unfortunately, and it's quite alarming, a lot of physicists can't say why we divide by r squared and not divide by r cubed, or not divide just by r, or some other factor. So it's good to get this clear in your mind. We divide by, so what is 4 pi r squared? 4 pi r squared, you probably recognize it as the surface area of a sphere. The surface area of a sphere. So the question is, why are we dividing by the surface area of a sphere? Okay, so let's answer that question. And first of all, let's point out that this sphere is defined by the distance. So in our example, we take the example of you and the Earth. This sphere is defined by the distance between the center of mass of the Earth and the center of mass of your body. So so the r squared, that's a radius. That radius is defined as the distance between the center of the mass of the Earth and the center of the mass of your body. So the two attracting objects, the distance between their centers of mass. So let's say we talk about the moon. The moon is being gravitationally attracted to the Earth. We want to work out that force. We divide by 4 pi r squared, where the r is the distance between the center of the Earth and the center of the moon. So why are we dividing by this? Why does this force get smaller as this sphere gets bigger and bigger? Because if you move away from the Earth, that radius gets bigger. You're moving away from the center of the Earth, so the radius gets bigger, which means the surface area of the sphere, 4 pi r squared, that gets bigger, but we're dividing by this surface area, so the force gets smaller. So that's why the gravitational force gets weaker as you move away from the Earth. So why is this the case? Well, then we're going to, as is current convention, we're going to talk about gravitons. So gravitons are the force-carrying particle of gravity. And then we'll explain this 4 pi r squared. So, the Earth is massive, it has mass, and that means all massive objects are emitting and absorbing gravitons. This is how the gravitational force is carried throughout the universe. All massive objects are in gravitational communication with each other by way of gravitons. Okay, so the Earth, as a massive object, is constantly emitting and absorbing gravitons. So now we imagine the Earth as this big sphere, and it's emitting gravitons all the time. So gravitons are being emitted from its perpendicular to its surface. So at any time, at any time, some number of gravitons will be emitted from the surface of the Earth. Okay, in all directions. So if you can imagine that at some time, some particular moment, some number of gravitons are emitted from the surface of the Earth, and are all emitted perpendicular to the surface of the Earth. So this creates a shell. So if you take a snapshot of it, let's say we'll let the gravitons all travel away 1 meter from the Earth. They're all a meter above the surface. This creates a shell around this, a spherical shell of gravitons around the Earth. Okay? And these gravitons keep on, they move away from the Earth. So as time progresses, these gravitons, the shell around the Earth that these gravitons are making expands, gets bigger and bigger and bigger. So we're talking about gravitons all emitted at the same time. So all the gravitons emitted at one particular time will create a spherical shell around the Earth. And these gravitons have a velocity and are moving away from the Earth, and that will cause them, this spherical shell will expand and get bigger and bigger. So it's like the Earth is in the center, and then there's this balloon of gravitons around the Earth, the shell of gravitons around the Earth that's expanding and expanding and expanding as the gravitons travel away from the Earth. Now, I hope you can picture this. So this is like a balloon expanding. But when this shell of gravitons expands, the gravitons are getting further and further away from each other. Just like if you blow up a balloon, the molecules of the skin of the balloon are stretching further and further apart from one another. So the further you are away from the Earth, the more this shell of gravitons has expanded, and the more spread out the gravitons are. Now, what does this mean? It means that the further you are away from the Earth, the less densely packed, the less densely together are the gravitons that you will encounter emanating from the Earth. Okay? Because they've had more time to spread out in this giant sphere. And the more that they've spread out, obviously, the less that will interact with your body per unit time, because they're more spread out. And this is why the gravitational force weakens as you get further and further away from the Earth, because the gravitons have had more time to spread out away from each other. So your body is 2 meters long. So per that 2 meters, there will be less gravitons per unit volume of your body. And because your body is having less interactions with gravitons, less gravitational interactions, it experiences a weaker gravitational force. Okay, so that's why we just divide, and it's very good to know that. That's why we divide by r squared, and we don't divide by r cubed or r. We're dividing by the surface area of a sphere, because that's the surface area of the sphere is proportional to how many gravitons will be in some particular area. Okay, so that's how Newton's law of gravity works. And then you know, in university, if you study physics, you work out how to apply this same law to not perfectly. You don't have to use perfectly spherical objects. You can just use different methods in calculus, and you use centers of mass to work this out for non-spherical, non-ideal objects as well, and it works perfectly for such objects as well. But that's the fundamental. That's how Newton derived his law of gravitation. Because Newton created one telescope. Telescopes were brand new. Telescopes allowed physicists, scientists to look at the planets and to really see that they were spherical. So Newton was one of the first people to really, really, really believe, like intuitively, that the Earth that he was standing on was actually a sphere. He wasn't the first person to have that idea, but he was the first person to really realize he was on a sphere, and then he realized the force was emanating outwards from that sphere, and therefore the force decreases according to the surface area of a sphere, which is why we have the 4 pi r squared. Okay, so that's the derivation of Newton's law of gravity. Now we need to add consciousness. Well, it's very simple. Gravitons are particles made out of energy, and all energy is conscious. Therefore, all gravitons are conscious particles. You as well are made out of physical energy, and all that physical energy is conscious. So when you're in the Earth's gravitational field, you are absorbing gravitons from her. And this is a physical process. But because all energy is conscious, it's also a conscious process. So what happens is when you absorb a graviton, and you don't just absorb it, you absorb it and then you emit it, but you emit it with less energy, and the energy that's lost by the graviton is the same energy that exerts a gravitational force on you. So two identical gravitons will exert the exact same gravitational force on an object. So when you interact with gravitons, we'll discuss the objective aspects. The physical process that takes place, the absorption and emission of the graviton, exerts a physical force on you in the direction of the center of mass of the object that emitted the gravitons. So in our case, it's the Earth. Gravitons come from the Earth, interact with your body, and this interaction is a physical process that very obviously has the result of accelerating you towards the center of the Earth. Okay, so now we add consciousness. The gravitons are simple conscious particles, and so is every particle in your body. So when a graviton is absorbed by some massive object and emitted by it, this has the physical effect of accelerating the object towards the gravitating object, the other gravitating object, and it has the conscious effect of creating. The conscious effect is that the particle that's being accelerated has a conscious sensation of a gravitational force in the same direction and proportional to the magnitude. Okay. Because similar physical processes give rise to similar conscious experiences. So a graviton being absorbed is a very regular physical process, and it has a regular concomitant conscious experience with it, which is the sensation of a gravitational force, which is just to say the sensation of a force. And that is why gravity is a universal conscious experience, because gravitons are the same all over the universe, and they have the same effect on all massive objects all over the universe. And it's a similar physical process all over the universe, and therefore it's a similar conscious experience all over the universe. So you can imagine yourself now, you are in the Earth's gravitational field. That means that you are having really a very, very large amount of interactions with gravitons per second. And these interactions with gravitons are pulling you towards the center of the Earth. and you have the conscious sensation of being pulled towards the center of the earth as a result, because of this, these physical processes, which are also conscious processes. So that is why if you go to another planet far, far away, and if it has the same mass as the earth and the same dimensions as the earth, when you stand on it, it will feel, in terms of the forces acting on you, it will feel consciously exactly the same as when you stand on the surface of the earth. So we can see that gravity is not just a universal force, it's also a universal conscious experience experienced by all the massive objects of our universe. Okay, so that's the basics really. And we can see how this is the beginning of conscious particle physics. Well, I began the physics of conscious particles in my essay on the truth about quantum mechanics and consciousness, where, for example, I talk about the conscious experience of electrons in a magnetic field, as well as the two-slit experiment, etc. But we can see that the basic premise is that regular physical processes give rise to regular conscious experiences. And that are the most basic and most fundamental physical processes of our universe also are consciously experienced as the most basic conscious experiences of our universe. So gravity, for example, is a universal conscious experience. Your dog, your cat, plants, they are all experiencing the force of gravity. That's why plants, for example, exhibit geotropism. They always grow vertically upwards within the gravitational field because they're having this gravitational force physically and consciously act on them. So yeah, regular basic physical processes correspond to regular basic fundamental conscious experiences. And from there, we can build up to the complexity of human conscious experience. Although humans are such complex objects and we have so many different kinds of conscious experience that obviously will take a long time to fully describe all of human conscious experience. Okay, but we should say, the last thing we're going to talk about, though, is the three realms. We do need to mention this. So we've done the basics. We've come up with the conscious derivation of Newton's law. But we just need to, we do need to make an important point about the three realms. So, yeah, what are the three realms? Well, there are different ways to exist as a massive object in our universe. You can be one of three things. You can be a single particle, a single center of consciousness, a single electron whizzing through space, having a singular conscious experience, just like you now are having a singular conscious experience. So is an electron. It's making certain decisions for itself. A very limited set of decisions. A human makes much more decisions for itself because it has more complex configuration and life. But an electron is making some decisions for itself, such as whether to align spin up or spin down with a magnetic field. See my lecture on quantum mechanics. So that's the first and simplest realm, singular particles, conscious particles. Then these singular conscious particles combined together into more complex objects. Okay? Like atoms, chemicals, rocks, guitars, things like that. So that's the second realm. The second realm, so singular particles are microscopic, but they combine together into larger objects. And then we have macroscopic objects. So that's the second realm. So the first realm is really simple. That's just an electron or a proton or whatever particle, a singular center of consciousness, physical center of consciousness. So you should understand what a particle is. A particle is you can't define exactly where a particle is or because of quantum mechanics. But you can say it is localizable. You can't say exactly where a particle is, but you can say it's somewhere within this range of space. And it's a localizable region of increased energy density. Like mass is where energy has the density of energy is increased in some particular localized region of the universe. And that energy is conscious, and this increase in energy density creates a singular center of consciousness within the particle. So when that particle is in a gravitational field, it has interactions with gravitons, and these interactions with gravitons exert gravitational forces on it, and the particle within itself experiences the gravitational forces just like you experience gravitational forces. Let's move on to macroscopic objects, the second realm. This is where a bunch of single centers of consciousness bind together. They do but so, a group of particles or a group of atoms bind together to form a rock or to form a guitar. But if you study chemistry, you'll know that the atoms and molecules bind together in very particular ways. A good example, I like the example of a crystal. Oh no, sorry, a diamond, I mean. A diamond is made of carbon atoms and nothing else. Just large numbers of carbon atoms, but they're in a very particular formation. Okay, they all exist on points of a crystal, what's known as a crystal lattice, which just is a regular pattern of where the carbon atoms are in the crystal. And it's a very, very regular repeating pattern. So any part of the diamond you look at, you'll just see carbon atoms in a particular pattern. Then you look at another part of the same diamond, you just see more carbon atoms in the same pattern. It's very, very simple. It's why a diamond is not intelligent compared to a human. Because all its particles stay in the same positions for the whole time, just vibrating in the same positions. Very unlike our brains, which are totally plastic, and you can change the positions of your neurons. Every time you think a new idea, it's a new configuration of neurons in your mind. A diamond can't do that, which is why, whilst it's conscious, it's not intelligent. It's in one basically conscious state all the time, because all its conscious components are in the same positions, and they're just vibrating depending on the temperature and pressure and such. Okay, but so you have a bunch of carbon atoms, which are single centers of consciousness. They bind together into a diamond, which means they all just link together, chemically bind together. And each center of consciousness within the diamond, if it's in a gravitational field, each carbon atom within the diamond will have a conscious experience of the gravitational field acting on it. Okay, but a diamond does not have one singular special center of consciousness like a human does. A human is different to a diamond because a human has a special center of consciousness. Okay, so in a macroscopic object, like a diamond, simple macroscopic object, all the constituent centers of consciousness will have conscious experience of the gravitational field. That's quite simple as well. It gets a bit more complicated with humans, because humans are exceedingly complex configurations of conscious energy. So it is more complicated than a diamond, for example. But it's quite simple. So what differentiates a human from a diamond? The answer is the central nervous system. The central nervous system. A diamond does not have a central nervous system. A human has a central nervous system and a brain. A central nervous system, like its name suggests, centralizes conscious experience throughout the entire physical object, that is the human body, a macroscopic object. And the central nervous system is embedded throughout that object and centralizes conscious experience to one center of consciousness. And in the case of your body, that center of consciousness is you. And as I said earlier, that's why you have conscious experience throughout your entire body, in proportion to how many nerves are embedded in particular parts of it. So, yeah. So every atom and molecule in your body is consciously experiencing whatever gravitational field you're in. That's just part of their conscious experience because they're in a gravitational field. But then you have your nerve fibers are connected throughout that body. And what your nerve fibers do is, since everything is conscious, so are your nerve fibers, so are your nerve cells. And the way nerve fibers work is nerve endings. Nerve cells have evolved the conscious ability, which is to take on whatever the conscious experience is of whatever they're embedded in. Okay? So nerve cells, I call them chameleon consciousness. They just take on whatever is around them. So, you have a nerve cell in your finger, some pressure is exerted on your finger, all the molecules of your finger consciously have conscious sensation of that pressure, and so do the nerve fibers embedded in your finger. Now it is a bit, I'm making, because I'm just doing the most basic theoretical physics of consciousness, I'm making simplified systems here. That's what physicists do. That's what Newton did. He made the Earth more simple than it is to explain the fundamentals. He ignored certain aspects of the Earth's physical construction and just said it was a perfect sphere, for example, which is not. There are many different types of nerve cells and ways that nerves communicate, but the basic way that nerve cells function is by sharing in the conscious experience of the part of the body that they are in. So when you put pressure on your finger, all the cells and molecules in your finger feel that pressure, and so does the nerve fiber that's embedded in your finger, and it sends a conscious transmission up your nervous system to your center of consciousness. It has to be processed by the brain first, but eventually it gets to your center of consciousness, where you share in a conscious impression of the conscious experience of your finger, for example. So then, this is also how gravity works. So your body is a big, complex object, and in terms of its center of mass, it's very complicated because you can change your center of mass. When you change the shape of your body, you change your center of mass. And a great example of this is actually the Fosby flop. I like this example. I hope you know what the Fosby flop is. It's when athletes jump over a bar. I'm not sure what it's called. It's not the high jump, is it? You just have to jump off the ground and go over a bar, and then you land on a big mattress. Well, people used to do this. They just would kind of run at the bar, facing the bar, and try and jump over it until some guy called Fosby came along, and he did it in a different way, where he went over it backwards. I'm not sure how people did it before him, but anyway, he broke all their records because of the shape his body took on whilst it went over the bar. So the way he did it was, as he goes over the bar, his body becomes an arch over the bar. And when your body makes an arch shape like that, your center of mass actually isn't in your body when you're in that shape. Your center of mass is kind of below the center of the arch. And if you study physics, you'll know that to raise something, to raise something to a particular height, you only need the energy to raise the center of mass. It doesn't matter how the body is shaped around it, you only need an amount of energy to raise the center of mass to a particular height. And so the Fosby flop is much more energetically efficient because your physical body goes over the bar, but your center of mass actually doesn't have to go over the bar, so you can use less energy to get over the bar, which is why the Fosby flop is the technique that all these athletes use now. So yeah, the human body is a bit complicated because our center of mass can change depending on how we position our bodies. So, and to control your body, you need an accurate idea at any given time of where your center of mass is, and this can constantly change depending on your position of your body. So evolution, over billions of years, and very impressively, has come up with lots of different ways of measuring the gravitational force acting on your body at any given time, depending on your position and depending on your velocity. And it does this by having different parts of your body being very sensitive to the gravitational force acting on them at any given moment. And these different parts of your body that are sensitive to gravitational forces, they're scattered throughout your body. And they're connected to your central nervous system. And the forces that are acting on these bodies and these parts of your body are centralized by your center of nervous system. And there's some processing done by the brain to work out, because it could depend on whether you have angular momentum or not. Are you spinning around? Are your legs tucked in? Are your arms out? So all these different measurements from different parts of your body have to be processed to some extent until a conscious impression can be given to your center of consciousness that gives you an intuitive conscious idea of the force acting on your center of mass of your body. Okay, so and that's quite complex biology and complex neurobiology, but the fundamental thing is that all these different parts of your body are interacting with gravitons and having a gravitational experience, a conscious gravitational experience that is centralized by your conscious central nervous system. Okay, so I'll give just one example to be brief. In your ear, you have these canals, small canals in your ear full of fluid, and projecting into the fluid are very fine hairs. And one good example is when you spin around, when you spin around on the spot real fast, and then you stop spinning, you still feel like you're spinning. So even though you've stopped spinning, for some reason you're still having conscious experience. Your conscious experience is, it's as if I'm spinning. That's why you fall over. That's why you can't walk properly, because you still consciously are experiencing spinning even though you're not spinning. This is because when you spin around, there's some fluid in these canals in your ear. The fluid takes on angular momentum, and angular momentum is conserved. So even after you stop spinning, the fluid keeps spinning in your ear. So then this fluid spinning is exerting a physical force on these hairs in your ear. And since everything is conscious, these hairs are conscious as well, and they're having the experience of this force acting on them. And that force is transmitted by your conscious nervous system to your center of consciousness. And it's giving you a conscious impression of we're spinning around really fast. Now the rest of your body, the rest of your force sensors are telling you that you're motionless, because they work in different ways. So that's why this is such a confusing state. You have one force sensor telling you you're spinning around. The rest of your body is telling you that you're stationary. The world around you is telling you that you're stationary as you look at it. And this is why this is such a confusing state, a dizzy state, and a state that makes you fall over and makes you feel nauseous. Okay. So by no means do I want to suggest that how the human body feels all the forces acting on it at some particular moment. It depends on the forces that are acting on it. It can sometimes be exceedingly complex. But this has been achieved through billions of years of evolution. Okay. But yeah, the fluid in your ear is still spinning around, which means the hairs in that fluid are still having a conscious experience of force, which is transmitted via your conscious central nervous system to your center of consciousness. Okay, so that is definitely enough for this part. Yeah, that's enough for this part. Okay. So in part two, so there we just expanded Newton's law of gravitation so that it is now a physico-conscious law, not just a physical law, which makes sense because gravity is not just physical, it's also a conscious experience. So we've linked the universal law of gravity, the physical, objective, universal law of gravitation, we've linked it with our subjective conscious experience of gravitation. And to repeat, just to repeat, because I do want this stuff to start getting out there, and I think humanity needs to face up to these truths, because they're very, very important. You know, humans need the most accurate and truthful understanding of their own experience, so that we can act most rationally and most sensibly. So to reiterate, it has been, this mystery of consciousness has been solved. There is only one possible solution, and that is by saying that all energy is intrinsically conscious. The fact that there exists no other theory, no other sensible theory that tells us how, if the energy and particles of our brains are non-conscious, then how on earth are we conscious? There's no theory that explains that whatsoever, or does anything, can be used to do anything. Whereas these principles can be applied to any conscious system. It does take a lot of work, but yeah. The fact that it makes sense of quantum mechanics and our theories of gravity and our theories of time and space puts it beyond all reasonable doubt, and it helps us to start analyzing how the human conscious experience is connected to the physical configurations of our bodies and brains. So do please take a look at the lecture on quantum mechanics. That's a very simple, logical, and intuitive interpretation of all the experiments based on the idea that quantum particles are individual centers of consciousness. And again, not complex, not like a human. They're not like, hey, I'm an electron, how are you? No, they just have feelings of force, feelings of gravity and things like that, magnetic fields, and they make very, very simple choices, such as spin up or spin down. The same way we see very simple animals making simple selections from limited sets of possibilities. Okay, so the range of things that humans have considered conscious has been constantly expanding for hundreds of years. At first, not a few centuries ago, philosophers doubted even whether creatures like dogs and elephants were conscious. Now, of course, we know that they're conscious, and now we know plants are conscious, and we know your gut biome is full of conscious bacteria. And this expansion of the set of what we consider conscious has expanded now till we realize that, actually it's all the energy is conscious. All the particles are conscious. They always have been. They just can configure themselves into more and more complex forms. And the more complex the form is, the more complex is conscious experience. And that is why you have such complex experience within your very complex human brain. But we could destroy your human brain and then you wouldn't have any of this complex experience anymore. Okay. So check out the lecture on quantum mechanics. And in part 2 on gravity, we'll move away from Newton's law, which we've completed now, and we will look at Einstein's theories of special and general relativity, and we will link the theoretical physics of time with our conscious experience of time. Okay, so that's it really. So check out that as well, and do try and share these with people. It's quite important that this does get out there, because it's been an awfully long time just reiterating theories that don't work, that start with the idea that basic energy and particles are non-conscious. That just doesn't work. Okay, so thanks for listening. I'll see you in part 2.